Hello there. We are back in the classroom today. We have our dress shirt on today and no hat. No hat. We've decided to be a little more professional today that we're in the classroom. And this is AP Statistics. We go over the same concepts here many times, which is okay, but let's do it once again. The big one for you guys, those of you who are taking the exam, who are still taking the exam, you need to make some arrangements for that exam on the 22nd, Friday, 2 o'clock. Remember, it will be done remotely from your computer, not in a classroom, not in a multi-purpose room, nothing like that. A 45-minute test. And I gave you on Friday, I read down through the whole memo. I'm not going to do that again. Look on Friday's video, and I went down through each step that you have to do. But today, there was supposed to be I think like a practice you could go through and just to make sure that you know what you're doing, practice up before. So look on the Friday video, last Friday's video for that. But I guess what I'm saying to surmise is if you're going to take the exam, you need to make arrangements before that Friday. With your computer and obviously your study techniques, because what I am doing here as we move along, they're all the topics that will be on an exam, but we're really going very, very slow. So keep that in mind. And today, remember, we're now in phase 3 of our virtual learning. What does that mean? Well, that means we're only going to have one assignment a week, according to Mr. McQuarrie. I was doing very short assignments anyway, but I'm going to follow orders and do one assignment a week. I'm going to talk 3 times a week here, but only have one assignment. And I plan on doing that on Wednesdays, so keep that in mind. So let's get to today. We all year long, have been doing the Z distribution. And if you remember, I said with the Z distribution, it never changes. It is a mathematical model that never changes. No matter what data, remember, you have to have the right kind of data to use it. What kind of data? Unimodal and symmetrical. Getting the glare off the I don't want that glare to go off my head here. So so I'm staying in front of the glare. Back to the Z distribution. Back to the Z. We are transitioning now. We have been talking about proportions here since, I don't know, a few weeks. We are moving on to means today. We're going to study mean. And you remember, I hope you do, that the mean is the symbol mu. So with means, something a little different has to happen. And it's kind of amusing, I don't know if you find statistics amusing. I do. I find it very amusing, very fun, and I just love it. But you may not, but this part you might. So if you turn to page 520 in your book, we will look at the origin of a new distribution called the T distribution, or specifically the student T distribution. Okay? Now, there was this gentleman by the name of Louis Gossett. No, that's the actor Louis Gossett. Sorry. I guess, do they have his first name? They just call him Gossett. Well, what his job was a quality control engineer for Guinness Brewery. Guinness is kind of like beer, you know, the alcoholic drink that you should not be drinking yet because you are not 21 years old. I don't think anyone out there is 21. But that was his job, quality control engineer. What happens as sample size goes up and you are a quality control engineer? That's the question, and I'm pausing for the answer. Answer, you might get drunk. And could you do a very good job at your job if you were inebriated? Nope. And this is not a made-up story. This is a true story. This is the origins of the T distribution. And what is going on here is in his job, he had to come up with a distribution that took into account small sample sizes, so small n's. So he changed and developed this thing called a student T. If you look down lower, it says student T distribution. And it changed its look based on sample size. So if, let's say you had a small sample, the tails would be fatter. And as the sample size got larger, as n got larger, the distribution became more normal all the time. So what I would have you know this morning, we'll get into this more on Wednesday and Friday, is with a T distribution, the distribution changes shape based on sample size, based on n, what n is. And n has a special little definition here. It is called the degrees of freedom. Degrees of freedom. And it is n minus 1. N minus 1. Remember, that gives us a little leeway. Remember, we learned about that with the standard deviation. N minus 1. Let me get out of the way here. All right. And so we've got degrees of freedom, n minus 1. And we're looking at the, remember, this is all now the T distribution. I thought it might be good at this point to kind of practice a little with our calculator to see what I mean by things change based on sample size. So if you get your calculator out, let us go where you're going to go. If you're looking for a distribution, the distribution key. So we go to second, vars, distribution. Remember, we have already done normal CDF and inverse norm. We have already done those. Let's go down to T CDF, T distribution CDF. It is the sixth option. And let's say, all right, let's do this. Let's go from, let's go for something we knew. Remember back with a Z distribution? With a Z distribution, we knew from, this was 34% on each side, 34%. So from -1 to 0 and 0 to 1, it was 34%. So let's look at that. I don't know if that's going to help us a lot because it's the tails. Yeah, maybe we should go out to the tails. All right, let's go back. to -2 and 2 and 3 and 3. So with a z, let's try z again. Sorry to jump around, but let's go to z again and do, all right, so go to normal CDF, and we will do, make sure there's nothing in the loop there, so clear that out, and do -99, so from the beginning up to -2. -99 up to -2 on normal CDF. So make sure you're still not in T distribution, which I was here. -99 to -2. And did you get about, remember, we said it was 2.5, it says 2.2, but I'm going to say about point, well, let's put it what it actually is here, 0.022, or we'll round off to 0.23, okay? That is for a z, and we went from way out here, -99, all the way to -2. Now, let's do that same thing with a T distribution. So hit second and go down to T CDF, just like a normal CDF. So this is T CDF, and we're going to go from the -99 to -2. Now they've got that DF there, degrees of freedom. So we'll change that some to show how it does change. All right, let's start with a very low number. Let's say we only had a sample size of 3. Let's say you were the Gossett gentleman and you were only sample 3 Guinnesses. Guinnesses, I hope that's what it is. Yeah, Guinnesses. So 3 minus 1 is 2. So we'll do a degrees of freedom of 2. And we hit paste. And we get, oh, that's exciting. I find that exciting. T distribution 0.091. Are you with me here? Oh, I did. I just kind of guessed here, but it really worked well. With a Z, this will never change. It from -99 to -2, it is always 0.023. We looked at a T distribution, and we had a very small sample size, which I told you makes the tails fatter. And from -99 to -2, it was 9.1%. Wow, that's big time. That's big time. I like it. All right, let's keep practicing, not experimenting. All right. So go back 0 to T CDF again, but rather than 2 degrees of freedom, let's go to, let's say he drank 10 Guinnesses. Whoa. So 9 degrees minus 1 is 9 degrees of freedom. All right, before you hit paste, I want you to guess, or not guess, you should know. Should the probability go up or down as sample size gets larger? I hear across the world, or across the greater Erskine area, everyone saying going down, and you'd be correct. So let's see what it is. Paste 3.8%. And this, remember, this was with a degrees of freedom of 2, DF of 2, and this was DF of 9, degrees of freedom of 9. Okay, let's say he really went for it. He went for it, and he drank 20 Guinnesses. I don't know how he would know the quality at that point, but we'll go with that theory. So he goes down, and 19, so we're going to put a degrees of freedom of 19. What would you expect to happen here? What would you expect to happen? I'm thinking it must be getting awful close to a normal curve again because the sample size is large. Let's look. It is 3%. Notice how that slows down as you get a larger sample. And this was with degrees of freedom of 19. Okay. That's what I really wanted to look at today, is that transition from a Z distribution to a T distribution. Oh, one other thing I could add in for you to think about until we do our problem on Wednesday is this whole idea of the standard error or the standard deviation of the sample. Remember, we have been doing SE for proportions is the square root of PQ over N. This is for proportions. But now for means, we've got something new, which is S, which is the sample standard deviation, which is the when you just take a sample over the square root of N. So we will be using this rather than this from now on, okay, with our formula. On Wednesday, when we do our little problem, we will do a one on Wednesday. Those of you who are keeping track of which would be an excellent thing to study for this test, is we did all the proportions. We did a 1 proportion Z test, 1 proportion Z interval, a 2 proportion Z test, and a 2 proportion Z interval. On Wednesday, we will do a 1. It's called, rather than mean, it's called sample. We're going to go with on the calculator anyway, it is a 1 sample T interval, a 1 sample T interval on Wednesday. Okay, so keep this one in mind. And I think that's going to do it for today. We will pick that up on Wednesday, and we will do that. We will do a 1 sample T, not P, interval. Okay? So we will see you on Wednesday. I hope you have a good day. Remember, you can make up those assignments that we've done if you haven't done them all. If you've done one and I haven't given you credit with a P2 on it, please tell me. I do not want to discourage anybody here. I want people to keep doing it. So I certainly wouldn't want to do that by not giving you the credit you have necessary. So please let me know that, and I will make the arrangement. Okay, I guess that's good enough for today. So we will see you on Wednesday. Goodbye.